Hey everyone, I just wanted to go over what we managed to cover at the end of lecture 1, which was the WAT.js video, and offer a little bit of an explanation for what exactly is going behind the scenes and how Bernhardt managed to get the results that he got at the end of that video. So first of all, just like as a reminder, we have basically five different literal types in JavaScript. So one, of course, are numbers. And those are just simply 1, 2, 3, and so on and so on. Next, we have strings. And strings are very simply, X, Y, Z, and things like that. We also have booleans. And booleans are just true or false. And we also have objects. So objects, as you all may be familiar with by now, they have like this little curly brace syntax where you put in a key and then an associated value. And then you can do this as often as you want. Now, arrays are kind of like an instance of objects. They extend upon the base object class. And even though they have their own literal, if they have their own literal declaration, they aren't quite their own primitive type. They're just simply an extension of objects. And we know this because whenever we did type of array, or if we pass in an array here, it actually would return object, which was a bit counterintuitive, but we explained why during class. And we'll explain this a little bit more during lecture 3 whenever we cover object-oriented JavaScript. So now, one of the things that I wanted to cover was just how the WAT.js video managed to get the results that it did. More specifically, these are the 4 different functions that Bernhardt, the person who gave the talk, managed to replicate. So first we have array plus array is equal to empty string. Array plus object is equal to this string object. This object curly brace syntax plus an array is equal to 0. Object plus object is equal to not a number. And then after that, he goes into the little WAT-man side. And I think the most significant part of that was just array.join 16. And, oh, sorry, just a second. So this is actually array 16, because we're instantiating an array with 16 blank elements, dot join, wat -1, and then we append the string Batman at the end of it. Okay. So let's just dive into the first example. Before we do anything, there is one thing that you need to know. So the addition operator in JavaScript is a bit unique, as are all things in JavaScript. So for addition, the way it works is that you just need to cast both sides of the addition operation, so this side and this side, down to their primitive values. So for numbers, their primitive values are, let's say if I wanted to get the primitive value of like the number 1, if I call toPrimitive, which is like the native code function for that. If I call toPrimitive on 1, I get 1 out. If I call toPrimitive on a string, I get the string whatever it was representing. Like let's say it was like toPrimitive on XYZ, I get XYZ out. toPrimitive on booleans, that actually outputs a number. So if it's true, it's 1. If it's false, it's 0. For objects, it's a bit different. So for objects, like let's say that we have like this literal type syntax here, calling toPrimitive on that would result in actually just calling toString on that object. So when I say toString, I mean, let's say that like obj contains our object, then we just call toString on that. So for any object that has like this literal declaration here, that's the equivalent of just outputting object. Now for calling or getting the primitive value of an array, well, recall that arrays are technically instances of objects. So whenever we get the primitive value of an array, since it is an object, we get the value back of whenever we call toString on that object. So in order to get the primitive value of the array, we basically just call toString because it's an object. So some background on that. So calling toString on an empty array causes it to output just empty string. Calling toString on a one-element array, sorry, I should put that sort of syntax there, will output 1, or whatever this element is. Then calling toString on any other size will output a comma-separated string of all the elements within the array, and so on. So, going back to our first example. So let's take a look here. So it's an addition operation. So that means that we need to cast both sides down to their primitive values. So recall here that we have that two arrays, which are instances of objects. And to get the primitive value of objects, we just call toString on each of those objects. So calling toString on each of these empty arrays, and we do this twice, that outputs empty string for each of those calls. And when we call addition on those empty strings, we're just basically appending those two strings together to eventually get empty string, which was shown in the video. Okay, so we're good on the first example. Now for the second example, it kind of just extends upon what we learned in the first. So let's look at this again. So it's addition, meaning that we cast both sides to their primitive values. Since both of these sides are actually instances of objects, we can then say that, like, okay, we're just going to be calling toString on each of these things. So for an array, calling toString on it will once again yield empty string. And then for an object, recall over here that whenever we call toString on an object, we're going to get the string out object. So whenever we append empty string plus this object string, we're just going to get out the string object, which was what was shown in the video. Good. So this third case is a little bit weirder. So once again, let's take a look. So this is the addition operator. Now, there is an issue with regards to how this is interpreted. This is technically something known as Unary addition. And why it's considered Unary addition is for the following reason. So in JavaScript, there's also this structure called a code block. And with regards to its primary use case, you won't really get any use of it unless you use ES6, which we'll get into next week. But the primary reason why we have a code block is that it allows us to create like this way of organizing our code so that you can just put some information within this separate code block. Note that this doesn't create a new scope. This just creates a new block to organize your code in. There are some operators in JavaScript that are block scoped rather than function scoped, and those are the let and const variable declarations, but we'll get into that next week. Regardless, a block is something that you can just put code in, and it just operates as normal. So whenever you just have this sort of syntax at the beginning of any line, JavaScript, the interpreter, will assume that you're actually creating a code block. This is a fairly useless code block because there's nothing in it, but regardless, it sees it as a code block. And since a code block isn't any sort of type of primitive value or anything that can really be cast to a primitive, the addition operator just sort of ignores this. And now it just sees that, like, okay, I have one operation on my right side. So this is something that is known as the unary case of addition operation in JavaScript. And the way that it's handled is, once again, a little bit weirder. So recall how normal addition actually just casts both sides to their primitive values. Well, in addition to casting the side of the primitive, its side element to its primitive value, the unary operator casts that primitive value to a number. So let's take a look. So for this unary addition, we're doing a unary add on the empty array. So unary addition tells us to do toNumber, i.e. cast to a number, toPrimitive of this empty array. That's just in the specification. So whenever we cast this empty array to its primitive value, as we've seen before, we get out an empty string. Casting an empty string to a number is actually just 0. So whenever we do this full operation, the first part is interpreted as a code block, so we essentially just ignore it. And then the second part is unary addition on an empty array, which is going to cast the array to an empty string and then cast that empty string to a number, which will then output 0, which is what we see in the video. Okay, so now let's move on to the second to last example. All right, so we have like this, bracket symbol plus other bracket symbol, and we get NaN. What's happening here? So recall how this part is going to be interpreted just as a code block. So once again, we fall into this case of unary addition. So in unary addition, we're going to do toNumber, toPrimitive on an object. All right. So also, you may be wondering, like, wait, why is this object considered like an actual object versus, this one being considered a code block? The only rule here is that if we see curly braces at the beginning of a line, then we're going to assume that it's a code block. Anywhere else in the line, it's totally fine to be considered as an object. So let's just continue with this operation. So recall toPrimitive on an object will output the string Object. All right, and now we're going to try and call toNumber on this. And this is going to output NaN, because there's no real number representation of a string object. To clarify exactly how strings get converted into numbers, the only cases that I know of are empty string always goes to 0, and then any sort of string of a number will go to the actual number itself, and then anything else like A, B, C, D, etc., is just going to go to not a number. So whenever we evaluate this operation here, we're going to see that, oh, this is a code block, we can just ignore that. And now we're doing a unary addition, so we take this object, cast it to its primitive value, which is just the string object, and then cast that to a number, which is going to yield NaN, so at the end we get NaN. All right, and then our last example is kind of like an extension of this sort of NaN type behavior. So let's take a look. So this array 16 syntax, all it does is that it just creates an array of 16 empty values. Next, what we're going to do is that we're going to call the join operation on this array. And what the join operation does is that it tries to basically cast this array down to a string. And it does so by replacing each of these commas with the string that you pass into this join operations argument. Well, the first argument most specifically. Okay, so now it's going to try and evaluate what exactly is this. So whenever we're talking about this, now we're talking about the minus operator. And the way that will work is to do the following. It's very similar to addition, actually. It's going to try and cast both of the sides down to their primitive operator. But it does something that's a little bit deviant from just the normal addition specifications in JavaScript. The minus operator doesn't just cast down to primitive value, it casts down to number directly. So whenever we have a minus, what we're going to do is that we're just going to call toNumber straight on both of the arguments. And this. Okay, and the reason for just casting straight down to a number is because the minus operator is inherently just a mathematical operation in most computer science languages. The addition operator has like some other reserved characteristics for it, such as it can actually work to concatenate strings and things like that. But for subtraction, you're inherently just going to be doing that for numbers. So we're going to be casting down WAT to a number. And recall, whenever we tried to cast down a string to a number earlier, as in up here, it's going to yield NaN. And let's see, the second side of this is going to be casting, well, an actual number down to a number, which is going to be 1. But per the rules of subtraction, NaN minus 1 is still NaN. So whenever we are constructing our array here, we're going to once again just be printing out a bunch of NaNs, 16 to be precise. So we have NaNNaNN, Batman. Okay. And that's about it. All right.